Welcome back, prep station physics. All right, want to look at another properties of waves. I've explained three now: reflection, refraction, and diffraction. Although I did that using the repo tank, I just wanted to create that impression that with the repo tank, you can study waves, behavior of waves easily, without looking at it that is an abstract topic. Okay. Now let's look at interference. What is interference? Just like the word interfere. What does it mean? When two things meet, when two things interfere, okay? Interference of waves. So the word interfere here, I think it has to do with more than one waves, okay? So interfere means having two waves coming together to meet. Yes, interference of waves. Two waves coming together to meet. But the interesting thing about this is when two waves meet, something happen. Okay, and that is what I'll be explaining here. Something happen when two waves meet. Now, when two waves meet, they interfere with each other. How do they interfere? Let's find out. If they meet each other exactly in phase, the amplitude add up to produce large crest and trough. If they meet each other exactly in phase, the amplitude add up to do what? Produce large crest and trough. Let me further break this down. By the way, interference is the overlapping. Let me use that word so that you can get the understanding better. Interference is the overlapping of two waves. Now, in this overlapping, something happen. Now, two things happen when waves overlap. If they overlap in phase. Now, what it means to overlap in phase is this. If the overlapping actually matches each other, if the overlapping happens in such a way that they are traveling in the same direction, that is to say crest to crest, trough to trough, now it's going to form what is called constructive interference. Constructive interference. Constructive interference. That is to say, if the overlapping, the outcome of the overlapping is what? Positive. Positive in the sense that they combine to form bigger waves. As you can see from the diagram, this is wave 1 plus wave 2. Now look at my right hand. What did you see? A bigger wave. Still the same wave, but this time around is bigger. That is because these two has combined positively. Now, why did they combine positively? Because they were traveling in phase. In other words, when wave 1 is going up, that is when wave 2 is going up. So they are in phase. Now, when wave 2 is going, wave 1 is going down, that is when wave 2 is also going down. So they are at the same position at the same time. When waves travel this way, they will form what is called traveling waves. They continue the journey and then form a bigger wave, just like what you are seeing. Now you may be asking, where can we actually see this happening? Have you ever been to a beach side, okay, where people go to play, swim, sometimes jump into the sea? If you have been to a beach side, you will experience this. Sometimes just look at the waves as they are coming. Sometimes you see smaller waves coming, and sometimes you see a bigger waves coming behind. What happens is that the combination of the smaller waves you are looking at, sometimes they mesh together to form what? Bigger waves, okay? That is constructive interference. Now, the second thing that will happen in overlapping of two waves is what? Destructive. Let me write it here. Destructive interference. Now, of course, from the word destructive, you should know where I'm heading to. Destructive interference. So what is destructive interference? Let me take you back to the diagram. Look at this now. If two waves meet each other exactly out of phase, the amplitude subtracts to produce no peaks or crest. What does that mean? Now, what does it mean to travel in phase? I've explained before. Let me explain again. Now, in destructive interference, if the two waves traveled out of phase, what does it mean to be out of phase? Look at diagram 1. Look at the beginning of diagram 1. is facing down. Look at the beginning of wave 2 is facing up. Just observe that. Wave 1 is facing down, wave 2 is facing up. So if these two waves are moving, what will happen is when wave 1 or wave 2 is going down, as you can see from the tail end here, look at my marker. So when wave 2 is going down, you can see this line. At that point, wave 2 will be going up. Follow the direction of this my arrow. When wave 1 is going down, wave 2 will be going up. Now, when you have two waves traveling in this manner, they will end up forming what is called destructive interference. So this is what is called out of phase. When the other one is going up, this one is going down. And when the other one is going down, this one is going up. So when waves travel in this format or in this manner, they will form what is called destructive interference. And what is the outcome of destructive interference? They cancel out. They cancel out on the condition that the two waves are equal. If the two waves are equal, they will just cancel out. They will form what? Nothing. Now you have a straight line. If I'm to demonstrate this on a device called oscilloscope, okay? Do you know what is oscilloscope? You can see one in the hospital. You know that device used in checking the heartbeat, the pulse from the heartbeat, especially when a patient is in coma, okay, just to know if the person is still breathing or is still alive. That device used where you have a beeping sound and then you have something moving like wave on the screen is called oscilloscope. Now, if I'm doing this with oscilloscope to check for destructive interference, what will come out of it is straight line. This straight line means no pulse. Just like in the hospital, when a patient finally pass on, that is to say dead, okay, you will notice that the pulse on the screen of that oscilloscope will just change to what? A straight line with a beeping sound, beep, instead of beep, 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 okay? So that is what you are seeing here right now. This straight line means the two waves have canceled out each other. Why? Because they are traveling out of phase. Now, sometimes they may not completely cancel out each other. It depends on if one of the waves is bigger. If one is bigger, what happens is that you are going to get an outcome that is smaller compared to constructive interference where we have bigger wave, okay? This one will be smaller. I hope you got that. What is interference once again? The overlapping of two waves. And this overlapping two things can happen. Number one, constructive interference, which is positive, two waves combine, form a larger wave, or destructive interference, two waves combine and cancel out. And I have given you the condition for this to happen. In constructive, the two waves must travel in phase. In destructive, the two waves traveled out of phase. Does that make sense to you? Okay, if that is, if you have gotten that, then let's continue. Young slit. To get two waves of light to interfere, the waves must be similar. Okay, to get two waves of light to interfere, the waves must be what? Similar. A single source of monochromatic light is used and split into two waves by using diffraction grating like this. What is monochromatic? Now, to understand that better, let me take you back to your elementary colors of light where you have the RGB, okay? Now, if you remember this, RGB, red for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, and V for violet. Now, monochromatic light is light that has only one color, Now, what I've written here is the outcome of white light. So every white light consists of all this color, the secondary color and the primary color mixed together. So a white light consists of this. And if you are able to split a white light to give you these 7 colors, okay? If you split a white light to give you these 7 colors, that is what is called dispersion of white light. Dispersion of white light is when you are able to get other colors out of white light. So monochromatic here refers to what? A single light. Single, maybe red, maybe orange, maybe yellow, it may be green, but it cannot be white. because white light is not monochromatic. Mono means one, okay? So monochromatic means just a single color of light. Now, if you are using that for the experiment, what happened? You can split that white light into two by using diffraction grating. Now, apart from diffraction grating, let me add this. You can also use what is called double slits. Double slit means two opening. Okay, this is L, double slit. Now, double slit can give you two waves. It will not appear as if you are using two sources of waves. So, if I'm using double slit, I can actually demonstrate interference with respect to Young's slit. In 1801, the English physicist Thomas Young, okay, that is the full name of the scientist, Thomas Young first performed this classic investigation which showed the interference of light waves. Yeah, before now, scientists believe that it's only sound that can exhibit the properties of interference. But then, Thomas Young in 1801 was able to demonstrate that even light can actually exhibit that same properties of what? Of interference, okay? So that is what we are looking at now, and I know this should be for the college students, okay? Now, diffraction and interference. Look at that now, see what is happening. Okay, this diagram illustrates what I've explained here. The source of light is one. So this yellow here, this yellow symbol represents the light, the source. Now, the first opening here is the first slit, okay? The first slit is to create what? A narrow light, a single light. Remember, if you don't use this slit, light exhibit transverse waves. Light travels in all directions. So you may not be able to get the result. So in order to get the result, we need to produce what? A single pulse of light. And that can be done by using a slit. In some laboratory, you can use what is called ray box. Ray box. This is something we can always improvise. You can even do it at home. Just get a lamp holder, get a bulb, okay? And then get a little box made of plywood, put the lamp holder inside, create a little opening. That will give you what? Ray box. Ray box is to help, is a device, okay, put together just to ensure that you can produce what? A single tiny source of light. So that is what we have here now. And of course, you know what will happen. When light passes through a narrow opening, what do you expect? Spreading out. And what is spreading out? Diffraction. Remember, I told you, diffraction is the spreading out of light waves. So the first layer here is diffraction. Now, after diffracting this light wave, there is another slit in front. But this other slit has what? Double opening. Remember, I told you, you can use diffraction grating to create two sources of light, or you can use what? Double slit. And that was what this wonderful scientist did, Thomas Young. Okay, so this is double slit, and then you can see S1, S2. What does that mean? Double slit, slit 1, slit 2. Now see what is happening here. After allowing this light to pass through, on my right hand, the diagram you're looking at is called the screen. Okay, so the screen will help us to see what is happening after the two sources of light interfere. Now look at the diagram. What do you notice here? Look at it very well. Now in S1, source 1, you have the wavefront. These are the wavefront being released in S1. And then in S2, you have wavefront being released, okay? Now in the middle, what do you have in the middle? Okay, both waves interfere at this middle. Can you see that now? They interfere at this middle. And how does that appear on the screen? Look at the screen here. Now, let's continue. Let's see what happened with that. Now, S1 and S2 are the two sources of light. The waves interfere. Constructive, bright fringes. Destructive, dark fringes. What is fringes? Look at it here on the screen. Okay? Now, what will appear on the screen is what is called fringes. Now, what is fringes? They are bands of spots of light. So you have some sections very bright, you have some sections dark. Okay, these are called fringes. Now, how do you know that there is overlapping? There is a positive overlapping where you have bright fringes. Remember I told you constructive is when the two waves interfere and form a bigger wave. Are you getting it now? So the bright fringes represent where the waves interfere positively to form what? A bigger wave. And that is seen by the brightness of the fringes on the screen. Then where you have dark fringes, it means the two waves overlap, but unfortunately they form what? Destructive interference, and then the outcome of that is the dark fringes. So Thomas Young was able to do this experiment to prove to other scientists that truly it's not just sound waves that can, interfere. Light can also do same with this experiment. So it was named after him, Thomas Young experiment. Okay, and not just that, this experiment has also been used to do further studies on light. Remember, we have the wave particle nature of light, wave nature of light, and then we have the wave particle nature of light. So Thomas Young experiment was actually one of the experiments that proves that light exhibits the properties of waves and then the properties of what? Particle. That will be a study for another day. Okay, now let's proceed. This is the front view of the fringes produced by Young's slit. This is the front view. What would the fringes look like if white light was used as the source instead? If white light was used as the source, what would have happened? That is a question for you to answer. If white light was to be used as the source, what would have happened? I think the fringes would have been mixed. Okay, I told you white light consists of other 7 colors. So it's not good to use white light. You better use color light so that you'll be able to get the outcome, a better outcome. Diffraction effects. What are the effects of diffraction? We looked at 2 before. So what are the effects? The colored fringes on this CD are the result of interference. I like using examples around. I like using things you can see easily, things you can touch. Now, this is a CD, this is a disc. I want to believe every one of us must have seen a disc before. Yes, everybody. Even though it's gradually phasing out because of USB flash device and all of that, but we still have them available for softwares, okay, computer softwares, PC softwares. Now, one thing about a CD is this. Whenever you pick up a CD and then you hold it this way, as you continue to change or tilt it in different direction, you are going to see different colors of light from a CD. Now, what does that mean? That is also the effect of diffraction, okay, on that CD plate. Now, if you look at the CD properly, you won't see any color. It's white, okay, sometimes silver color. But when you begin to change the direction, allow lights to, hit on it at different direction, you see different colors of light. So what does that mean? That is diffraction. The colored fringes on the CDs are the result of what? Interference, okay? First, the light diffract, they interfere, and then the interference causes what? Color. The color you are looking at are the different interference at different level. This is happening because it's white light. White light consists of what? Different colors. So when you subject white light to this, the different colors will interfere, and then you will see all of this happening. It will not look as if the CD is producing different colors. Light reflecting from the aluminum coating diffract and interferes. Do you hear that now? First, it diffract. Secondly, the diffracted light interferes. And because we are dealing with white light, and white light consists of 7 other colors, then this is bound to happen, okay? If it's a single color of light, you will not see this. If it's a single color of light, but because it's white light, you will see this. Some colors are diffracted more than the others. So what were we looking at today? We're actually looking at how to use the ripple tank to study the properties of waves. The only property I've not mentioned in this series is what? Polarization. Polarization is only applicable to transverse waves, but I've mentioned the other four: reflection, refraction, diffraction, and interference. And these four can be studied at home using the repo tank. All right, thank you so much for staying with me through this lesson. So far, so good. We have considered what is waves, types of waves, okay, using the different medium of classification, direction for propagation, material for propagation. We have also looked at the terms using describing waves in detail. And then finally, we were able to look at the properties of waves, which are 5 in number. And we have explained all of that. I want to believe you have learned something. Okay, I wish you success in your exam until I come your way again.